Now we're going to talk about the Laplace of the integral equations. In this, usually the form, and it will be the form for us, will be the form of the convolution. So remember, the convolution of f convoluted with g has this integral form 0 to t f of tau g of t minus tau d tau. And don't forget that it can look like this also, where f is the t minus tau function and g is the tau function. It does not matter. Either way is fine. So I used the same approach I did with differential equations, the three-step approach. I'm going to take the Laplace transform of everything, solve for the Laplace of the unknown function, and then take the inverse Laplace. So I've got two examples. Let's do this one first. So I'm going to take the Laplace of both sides. The Laplace of a sum is the sum of the Laplaces. I can factor out constants. So I take the Laplace of everything. Now let's apply our formulas that we know. So the Laplace of the unknown function I'll call f of s. 2 times the Laplace of t, well, of course, that's 1 over s squared. Minus 4, well, this is this. This is the convolution of sine with f. So convolution of sine with f. Well, what's the Laplace of the convolution? It's the product of the Laplaces. So this would be the Laplace of sine is 1 over s squared plus 1 times capital F of s. So now that I have that, that's step 1. Now step 2. What I'm going to do is I'm going to take the f of s's together, put them together, and solve for f of s. So I have f of s. I'm going to factor, so that's 1. So it'd be plus 4 over s squared plus 1 equals 2 over s squared. That was easy enough. I took this over the other side, factor out an f of s. Well, let's get a common denominator here. So this is f of s. So this would be s squared plus 1 plus 4 over s squared plus 1. 1 plus 4 is, of course, 5. Equals 2 over s squared. So now, let's take this guy over the other side. So we have f of s, and there should be an arrow there. So f of s equals 2 over s squared times, flip it, so this would be s squared plus 1 over s squared plus 5. So this becomes 2 over, the s squareds cancel out on that first term, so 2 over s squared plus 5 plus 2 over s squared times s squared plus 5. Now, think about it. This one I can do. I have to do some reorganization, but this one I can do. This one, though, it's going to take a little work. What comes to your mind? Partial fractions. So let's set it up. I'm just going to set up 1 over s squared times s squared plus 5. That's equal to a over s plus b over s squared plus cs plus d over s squared plus 5. So what do we get? We get 1 equals a times s squared plus 5 plus b times s squared plus 5 plus cs plus d times s squared. So what do I get? I get 1 equals, let's multiply all this out, so this would be as cubed plus 5as plus bs squared plus 5b plus cs cubed plus ds squared. So now let's put oranges with oranges, kumquats with kumquats, watermelons with watermelons. So I've got A and I've got C. So A plus C equals 0 because there is no s cubed there. I've got a B and a D. Same thing, there is no s squared, so that's 0. I've got, looks like my only s, so I've got 5a equal to 0, so that guy means a equals 0, which by the way means c equals 0. So that one's easy. And then finally I get down to here, I got 5b equals 1, so b equals 1/5, so d equals minus 1/5. So now I've got this broken up. A is 0, so that guy's out of there. C is 0, so that guy's out of there. So what do I end up with? Let's continue right here. So I have 2 over s squared plus 5. B is 1/5, so that'd be plus 1/5, 1 over s squared. Okay. Times, though, I don't need to forget it, this was times 2, so this would be a 2 over that. Don't forget there was a 2 here. So multiply by the 2. And then I'm also going to do the same thing with the d. Don't forget to multiply it by 2, so this would be a minus 2/5, 1 over s squared plus 5. Okay? So now, let's sort of put this together even more. So I have 2/5, 1 over s squared. I've got that. Now let's think about this. 2 minus 2/5. So that's 10/5 minus 2/5 is 8/5. And I've got 1 over s squared plus 5. But let's look. I can take the inverse Laplace of this. This one, I need a square root of 5. So let's just multiply by a square root of 5. But if I do that, I must divide by a square root of 5. Therefore, now I've got f of s equal to this. So f of t equals the inverse Laplace. This is third step. Inverse Laplace, because I finished the second step by solving for f of s. Third step, take the inverse Laplace. So this would be what? 2/5 t, I got that, plus 8 over 5 times the square root of 5. Now, what's the inverse Laplace of this? Well, isn't that sine square root of 5 times t? 8 over 5 square root of 5 times the sine square root of 5 times t. So this is the solution to this integral equation. Let's do one more to make sure we understand. First step, take the Laplace of everything. What's the Laplace of t? Well, the Laplace of t is 1 over s squared minus 2 times capital F of s, because that's the Laplace of my unknown function. Now, let's take a look over here. Well, I've got a tau, I've got a t minus tau. So if you think about it, this is really two integrals. e to the tau f of t minus tau minus e to the minus tau f of t minus tau. That's one way to look at it. So what do you get? What's the Laplace of the convolution? It's the product of the Laplaces. So what's the Laplace of e to the t? Well, think about it. That would be f of s over s minus 1. Then this one minus, it'd be f of s, because it's the product, over s minus a negative 1. So that'd be s plus 1. So that's what I get there. So let's put all the, I guess let's go ahead and take all the f of s is over there. So I have 1 over s squared equals f of s 1 over s minus 1 minus 1 over s plus 2. Now plus 2, because I took this guy over here. If you don't mind, we're just going to simplify this. Let's get a common denominator. It's going to be s minus 1, and that should be a plus 1 right there. Sorry about that. I was thinking ahead on the plus 2. So let's get a common denominator, s minus 1, s plus 1. So that would be s plus 1 here minus s minus 1 plus 2 times s minus 1 times s plus 1 all over s squared minus 1. Okay, so I get f of s. So this would be s plus 1 minus s plus 1 minus 2s squared, that's a plus 2s squared, minus 2 all over s squared minus 1, s squared minus 1. So those s's cancel out, the 2's cancel out. So I end up with f of s times what? 2s squared over s squared minus 1. So now this all still equals 1 over 1 over s squared. So flip it. If you don't mind, I'm going to write the f of s on this side. So this would be 1 over s squared. Flip it. So this would be s squared minus 1 over 2s squared. Well, what does that equal? The first term, it'd just be 1/2 1 over s squared, right? The second term, minus, well, I'm going to get 1/2 1 over s to the 4th. Okay, now I look at this. This is close, but it's not exactly what I need to take the inverse Laplace. What am I missing? A 3 factorial. 3 factorial is 6. So multiply by 3 factorial, divide by 3 factorial. So what do I get? I get 1/2 1 over s squared minus 1/12, and this would be 3 factorial over s to the 4th. Well, therefore, I'll come here. Last step, take the inverse Laplace. So this would be f of t. What's the inverse Laplace here? So this would be 1/2 times t minus 1 over 12. What's the inverse Laplace here? That's t cubed. So that is my solution to this integral equation. The same 3 steps that we did before. Take the Laplace of the entire equation, solve for the Laplace of the unknown function, and third, take the inverse Laplace to find your solution.